one thing. All right, here we go. Yeah, this is an example here that I have up on the board as an example of the type of equation that we'll mainly be dealing with, x plus 2y equals 5. And of course, the main difference between that equation and previous ones is that I have x and I have a y. We did talk about a few formulas that had 2 or more variables in it, but these almost all exclusively will have 2 variables, an x and a y. Now what that means, one thing that means is we are going to need 2 parts to be a solution to these equations. For example, x is 1 and y is 2 is a solution to that, isn't it? Because how do I know that? Well, if you plug in x to be 1, y to be 2, you get the left side equals to the right side, okay? However, there's a lot more complication to it because that's not the only one that fits in that. You know, when we were solving those linear equations, usually we got one answer and that was it. Well, not the case here, because if I choose x to be 3 and y to be 1, wouldn't that work? Ditto. Also a solution to that, right? X could be 3 and y could be 1, and that would be a solution. So first of all, there's 2 parts. There's an x and a y. And then also there's going to be multiple solutions because that, I mean, there's actually lots of others. And we'll explore more in detail in just a second. So that, first of all, is what I wanted you to see. There's many others to follow. We could play the same game there, and we'll talk about how we'll do that in just a second. All right. Now the other thing is, yeah, we're going to throw in a little bit of graphing to this because since we've got 2 parts. Oh, before I mention that, let me also mention one other way that we can, instead of having to write that whole thing every time, what we can choose to do is write it as an ordered pair. So we don't have to write specifically out x equals 1, y equals 2 every time. Yeah, if I write as an ordered pair, I write the x first and then the y, ordered because it goes in alphabetical order there. X is first, the y is second. If I do that, then I could say, well, 1 comma 2, that's a solution. 3 comma 1, that's a solution, and then others as well. But you see that instead of to write x equals 3, y equals 1, I can just simply write 3, 1. And that means x is 3, y is 1. Okay. All right, so yeah, now back to what we were talking about as far as graphing. Since we need a combination, an x and a y, when we go to graphing these solutions and these equations, we are going to need 2 things. We're going to need an x-axis, and then we're going to need a y-axis for somewhere to put our y values. And so let's talk about those for just a second. When we go to graphing those equations there, yeah, we are going to need a number line for the x. 0, 1, 2, 3, back -1, 2, 3. All right, so that's going to be the x-axis. But then we're also going to need a combination with that. We're going to need a y-axis. And the way we usually do that is put it perpendicular there to the x-axis. This will be for our y values. And then they're going to intersect there at zeros. That's 0 in the x and the y, and then the y's go up, right? 1, 2, 3, 4, 5, 6, and then down are the negatives. so forth and so on. This gives us a way then of plotting the solutions or marking the solutions on graph paper or in a graphing setting. For example, now what we also might note there is the with these x and y axis, this is by name. Sometimes you'll hear it referred to as the Cartesian coordinate system. So called because of the first one to actually develop this. Cartesian is for his name, and then coordinates. So yeah, what we're able to do is put down coordinates for each point in this system here. We'll talk about that more in just a second. Well, I was also going to mention before I get started on this is the idea of quadrants. This x and y axis, the xy plane, also sometimes it's referred to, because it covers a plane is just a flat surface. But it divides, the x and y axes divide the plane up into 4 parts. You've got an upper right, then upper left, and then the lower 2 down here. Those are called the quadrants, and they start the numbering by numbering the upper right one, quadrant 1, and then going counterclockwise 2, 3, and 4. That way. All right. So sometimes we'll refer to that, and they may ask about that. So you know. Okay? All right. Now, like I was saying, what the Cartesian coordinate system allows us is to give a name to every point that we could possibly come up with in this plane. For example, if I wanted to go to this point right here, well, we'll notice that is in the x direction 3, but in the y direction 1. So that point would have the name 3, 1, wouldn't it? Based upon our ordered pair discussion we just talked about, right? Because that's x is 3, that's y is 1. So that combination there gives us that coordinate, those coordinates for that point. And so we can do that for each and every point that we have. That's in quadrant 1. What quadrant, where would -5, -2, what quadrant would we be in there? Quadrant 3? Yeah, because that's saying x, it's always the x first, the y second. So I'd go in the x direction, -5. So that'd put me there. And then -1 in the y direction, which is right there. So yeah, quadrant 3. Upper part there, quadrant 3. All right. So what about this one? What quadrant is that one in? 5, -10. Quadrant 4? Yeah, so we go in the x is 5. Yes, x is first, then the y, so that would be down. -5, +10, yeah, we'll do that one. That one would be here, wouldn't it? Put it right there, okay. So there's your 5, -10. If we switch that, we're talking quadrant. That'd be 2, right? -5, +10. Say 10 is right there. Yeah, so that would put me right there. Somewhere in that vicinity anyway, okay? Yeah, so depending upon which one's negative, which one's positive. Now, also note here, you can do fractions, you can do decimals. If I did -3.5, comma 1/3, is that possible? What quadrant? Well, that would be 2 or 3. One or the other, probably. Yeah, quadrant 2, wouldn't it? Negative 3.5. So we'd go halfway between negative 3 and negative 4, and then a third up for the y. So that would be somewhere along in there. Okay. So yeah, you can do fractions, square roots, any sort of thing for the x and the y values. All right, what quadrant is this one on? In. Six, 0. It's in 1. Why not 4? It's actually between. It's a trick question. Okay, I gave you a trick question there. It's actually not in a quadrant there, is it? Because it's actually on a boundary line. It's actually on an axis. So it's in between quadrants 1 and 4. So I kind of gave you a trick question there. Yeah. You can have points right on the y and x axis. How would I get one on the y axis? Do a 0 for the x, and then like this one, that would be 0, 4, wouldn't it? And we'll say more about that in just a second. Okay. Those are technically not in a quadrant, but on the x-axis, and like I said, those will come into play a little bit more here later on. But is that okay? Any questions or concerns more on that? All right. Well, let's go back to the equation and make the link here between the equations and then this graphing stuff. Like I said, most of the equations will look similar to the one we first talked about. Here's, I think it's not quite the same one as I was doing earlier, but x plus 2y equals 8. Like we were saying, how many solutions does this one have? A bunch. Infinitely many, actually, if you really get down to it. There are a lot of solutions to this. For example, 4, 2 is a solution. 2, 3 is a solution. Check me on these. 0, 4. Negative 2, 5. How do I know those are all solutions? Well, if I plug those in, x to be 4, y to be 2, the equation works, right? 4 plus 2 times 2 is 4, so that's 8. 2 and 3, x is 2, y is 3, that's 2 plus 6, that equals 8. 0, 4, 0 plus 2 times 4, that's 8. Negative 2, we can also get some negatives here. Negative 2 plus 2 times 5. Isn't that 8? That's 8 too. So there's lots and lots of different solutions. And we'll talk about how to come about with those. But for now, just note those. Maybe one more. How about 8, 0? That would be another one. Okay. All right. Now, can I just put any two x and y's together? Like, could I do 5, 1? Now, there are specific ones. 5, 1 wouldn't work, right? 5 plus 2 times 1? No, that's 7. It's close, but not close enough. All right. So there are specific points that we're talking about, ordered pairs. So it's not just any two we put together. There are specific ones. Also, while I've got this here, another way we can arrange the information here, these solutions, is in a table, sometimes called a t-table or an xy table, where you just list the x and y's across from each other. X is 4, y is 2, x is 2, y is 3, x is 0, y is 4, so forth and so on. All right, so just another way they'll have you do these. A nice compact way of doing it. All right, but let's look at here how these solutions are all working over here on our Cartesian coordinate system. If I plot each of those points, let's see what happens. 4, 2, let's plot it. 2, 3, x is 2, y is 3. 0, 4, 0, 4. Negative 2, 5. And 8, 0. Notice anything about these points? They're all lining up, aren't they? Yeah, any point we could come up with in our table or as an ordered pair there, any point that we find for this equation is going to line up with those other points. In other words, all points that we could come up with are going to be in a straight line. Well, so if we connect the dots here and then extend it out this way, extend it out this way, what we've done there is we've graphed the equation x plus 2y equals 8. It's a line. Meaning the solutions to x plus 2y equals 8 are going to be on that line. That's all the solutions of the equation that we have here, x plus 2y equals 8. That's called the graph of it, and it is a straight line. All right. Now, turns out that any equation similar to the one that we had here, the one that I think the first one I did was x plus 2y equals 5, right? That equation, this equation, always will have a line. Anything that's similar to it will have the same shape. It will be a line. Now, it won't be maybe slanted this way, but it will be a line. Now, what is the key components, I guess? Well, you remember we talked about linear equations. Well, this is a linear equation in two variables. And remember what linear referred to as far as the variable is concerned? It was power of 1. When we get to x squared equations and x cubed equations, there will be different solutions to that and different graphs. However, a linear equation in two variables is just like this. It's x to the first and y to the first. There's only first powers in your equation. Anytime you have that scenario, you are going to have